Hello students, today we will discuss analysis and design of circular column. This topic is from Structural Design 1, 4th Sem, Civil. Okay, subject code is Theory 1. So the question is design a circular column of diameter 400 mm subjected to a load of 1200 kilonewton. This column is having spiral tires. The column is 3 meter long and is effectively held in position at both the ends but not restrained against rotation. That means both the ends are hinge support. Okay, you can see here both the ends are hinged. It is held at both the ends but not restrained against rotation, so it can rotate. So both the ends are hinged. Use M20 and F415. So this is FCK 20 Newton per mm square. This is FY 405 Newton per mm square. Okay, you can see here the given data are there. Length is 3 meter, P is 1200 kilonewton, diameter is 400 mm, FCK is 25 Newton per mm square, Fi is 415 Newton per mm square. So as you know, both the ends are hinged, so effective length is 1L as per IS 456, so L effective is 3 meter. So slenderness ratio lambda is L effective by D, that is the least lateral dimension. So 3000 by 400, that is 7.5, and this is less than 12, so this is a short column. Next we have to check about our eccentricity. Eccentricity E minimum is effective length divided by 500 plus least lateral dimension by 30 as per IS 456. The value is 19.33, that is less than 20. Okay, so we have to check whether our E minimum is less than equal to 0.05 D. So that is 0.05 D is 20. Our E minimum is 19.33. Okay, then we will move forward for our given formula. Okay, so area of the steel, we have to find out first for design of the column. We have to find out first area of the steel, ASC. Before that, that is ultimate loading. PU is, that is axial compressive load, that is acting on the column. So P is given, so PU is 1.5 P, that is 1800 kilonewton. As we are designing for circular column with helical ties, we have to multiply 1.05 in our given formula. Where we got this formula, the generalized column formula is PU is equal to 0.4 FCK AC plus 0.67 FY ASC. This is the generalized formula for column. How to get this? We have to check E minimum is less than 0.05 D. So if that is the case from IS code IS 456, we will get this formula. But this is for generalized case. But when we are designing for circular column, we have to multiply 1.05 in this. Okay. So as the diameter of the column is 400 mm, as the diameter of the column is 400 mm, the gross section area is pi by 4 D square. This much value is there, 125,663.7 mm square. So how to calculate the AC? AC means area of the concrete. Suppose this is the column, this is the gross area AG. So from this gross area, we have to remove this portion, the reinforcing portion. Okay, then we will got the area of concrete. This reinforcing portion area is, suppose this is the reinforcing portion, this reinforcing portion area is ASC. Okay, so from AG, if we remove this ASC, we will got the concrete portion. So our concrete AC is, our AC is 125,663.7 minus ASC. Now what we will do, we will put this AC in this ASC. So all the values are known, PU is known, FCK is known, FY and FY is known. Only unknown is ASC. Okay, ASC is the only unknown. Okay, so we will got ASC as 1793 mm square. So percentage of steel is ASC by gross section area, that is 1.43. We have to check whether it falls under 0.6% to 8% as per IS codal provision. If that is the case, that is okay. Now we will use, suppose we will use 20 bar. The area of the one bar is cross section area is 314 square, plus this much area ESC. The number of bars are 1793 divided by 314. So when we will do 1793 divided by 314, we will get 5.71. So nearly 6 numbers of bars are required. Okay. So provided 6 number of 20 diameter bars. So ASC provided, this is the actual ASC, this is the actual, this is the provided 6. So ASC provided is 6 pi by 4 20 square, that is 1884 square. Now we will go for helical reinforcement design. Actually we have got the main bars, how many main bars and what is the diameter. Now we will go for the helical reinforcement. So the core diameter is, you can see here, this is the outer diameter 400. The core diameter DC is 400 minus clear cover, that is 50. So 400 minus 2 into 50, that is 300 So area of the core is so we have to we got the diameter, that is 300. So pi by 4 300 minus this steel portion, this 6 numbers of bars. Okay, so area of the core is 6880.5. okay. So now the volume of the core, so this is pitch, okay, and this is the our 6880.5, okay, area of the core. Now the volume is 6880.5 into P. Now we will discuss volume of helical reinforcement. Okay, so volume of the core per page is 6880.8 into P. Suppose we will use 8 spiral, 8 diameter spiral. Volume of the one spiral per piece is, okay, and let's see. We have got the volume of core. Now we will decide the volume of spiral. This is the spiral, this is one spiral, this is the front view of the circular column arrangement. This is the top view, this is the top view. You can see here, this is the core diameter. So volume of spiral is, okay, volume of spiral per piece is, you can see here, this is the DC from outer to outer, this black dot, this is the DC portion. Okay, so from center to center the dimension is DC minus 8, that is 300 minus 8. This is the diameter. So length is 300 minus 8 into pi. When we multiply the area pi by 4 into 8 square, we will find out the volume of our one spiral per pitch. Okay, this is the volume of one spiral per pitch. So 300 minus 8 into pi by 4 8 square. Okay, so the volume of helical reinforcement divided by volume of core, we will get this much value. So for IS provision, IS 456, this value should be less than equal to 0.36 into AG minus AC minus 1 into FCK by Fy. So P should be greater than equal to 37 From this condition we will get P should be greater than equal to 37 So maximum pitch should not be greater than 75 or pi by 6. So core diameter is 300 by 650 okay, or minimum is 25 or 35, that is 24. So provide from these 4 conditions, provide 8 diameter spirals at 40 center to center, because there should be greater than equal to 37, should not be greater than 75. So we will provide 40. Okay, minimum should be 35, 25. Okay, so we will provide 40. So you can see here the arrangement you can see here, this is the main bar. So 620 mm diameter bar. Okay, 6 bar. You can see here, this is the main bar. So this is 620 mm diameter bar, and piece is 40. The diameter is 85. Okay, this is all about our circular column design. Thank you.